Welcome back. Welcome back. What is that? Is that a plane coming out? That's just what happens when you try to teach outside. You never know what noises you're going to hear. You might hear a car horn, especially if you're in New York City. You might hear a plane. You might hear some ACs. But, that's just the sound of the summer. So, we're going to be doing our summer school kickoff with just our first lesson here for Algebra 1. We're just going to keep it slow and cool. Hopefully, you're keeping that cool out too. So we're just going to be talking about first about the distributive property. I know that for your do nows, you guys have looked at other properties. You guys have gone over it. I know in middle school and this first year of algebra about the communicative property, about the associative property. We're going to focus the rest of our lesson on the distributive property. So let's just start with some of those basics on what is a distributive property. Also known as the distributive law of multiplication. It's one of the most commonly used properties in mathematics. So when you distribute something, that's about you passing out. Let's say you have a pie or a bunch of food. You get like a combo, and you're just dividing that into parts. So this property helps make difficult problems a little bit more simple because it breaks down expressions into the sum or difference of two numbers. Okay, so that's what a distributive property is. We are breaking down a problem into parts. Makes it a lot easier. You probably have seen an image like this about a distributive property explained here. So we have here 4 times, we have that in parentheses a variable x plus 3. So you see these arrows here. We're going to be distributing, or in that case, passing out the 4 amongst the x and the positive 3. So think about it as the 4 is going to be shaking hands with the whole table, right? Let's say you're coming over and you see a bunch of your friends. You're not going to say or shake hands with just one of them. You're not going to just shake hands with x. You're going to shake hands also with the plus 3 there. So 4 shaking hands or multiplying with the x is 4x, and 4 shaking hands or multiplying with the positive 3 would give us plus 12. So simplifying that expression right there gives us 4x plus 12. Let's think about some everyday examples here. I want to see how am I going to use the distributive property here. So if you don't know yet, I love going to concerts and festivals. Let's just look at the Governor's Ball here. This is going to be down from September 24th to the 26th. See, who do I want to see here? I don't know. You kids love Billie Eilish for a reason. Not really my type of person. But the baby, Freddie Gibbs, who else? I was 21 Savage. Yeah, sign me up for those. So let's say I want to buy tickets. And so, usually I don't go to these alone. Let's see. Let's say we're going to go Friday, right? Because you guys be like, oh, I want to see Billie Eilish. So I'm going, and I know that the general admission is $129. Let me just write that down here. So GA, that's just general admission. I know one day, $129, but you get to see like 10 artists in a day. So it's like putting in 10 concerts in one day. So general admission, that's $129. So I know I want to go, and I usually go with 3 cousins of mine, right? So they're always down to go. At the same time, the day is coming up, probably be in August or the beginning of September. And what always happens, I'm not sure if your friends are like this too, but sometimes people be hopping on last minute to do something, even though I told them months ago. So I know I'm going to have 4 friends that be like, let's go, we should have fun, let's go. Last minute. But let's say it's all going to be on my credit card. Always going to be on my credit card. So on my credit card. Fine by me, I get those points, and all my friends are probably gonna pay me through Venmo. I am definitely not accepting Cash App from them. No way. Okay. So how am I going to break down what is going to be the total of this price using the distributive property? Well, I know that, let's say I'm including myself in here, right? So let me just make it 4 cousins because I'm in there. I'm a cousin too. So let's say the tickets cost, as we saw there, $129. That's for each person. But I also have to pay for those 4 cousins, including myself. Plus, you know what? I said 4 friends, but I know at the same time I'm gonna have my boy JT. JT is gonna come through last minute, so let's make it 5 friends. So I know I'm paying for the 4 cousins plus 5 friends. So I need to figure out what is going to be the total price for that. So let me just distribute that $129 amongst us 4 primos and the 5 friends that are tagging along. So what that means is I'm going to be multiplying $129 amongst the 4 cousins, plus I'm going to be multiplying the $129 amongst my 5 other friends. So now I can multiply 129 with 4. Take my calculator there, I'll see that this is going to be $516 for 4 people. And if I'm multiplying the $129 here with my 5 other last minute friends, that's going to be 129 again times 5. That's going to be $645. So now let me add up the total amount there. So 645 plus 516, that's going to be $1,161. Yep. So for these 9 people to go for that one day, who are we gonna go see again? We get that plane already going. That plane's already heading there already. For 129, and if I'm gonna go on Friday, so $1,161 just so we can see on Friday. It was Billie Eilish, The Baby, Leon Bridges, Portugal the Man. Let's see, Future Islands, Freddie Gibbs and the Alchemist, Earth Gang, Odie, Looney, Nasty Cherry, all these people there. The total is going to be $1,161. So let's say we're working with other algebraic expressions. Let's use this blue color here. Let's say for problem number 3 here, I'm multiplying 6 with negative 5n plus 7. So I'm going to be distributing. Make sure you show those arrows. You're going to be multiplying 6 with negative 5n. And you're also going to be distributing the 6 with the plus 7. So all that means is 6 times negative 5n plus 6 times 7. So 6 times negative 5n, a positive times a negative, is going to give me a negative 30n plus, and 6 times 7 is going to give us 42. See, I'm done with that. I'm just going to box my answer right there. Even up here, let's do another example. Let's do number 4. Actually, let's do number 6 since it's dealing with more negatives here. We're going to be distributing again the 8 with the negative b, as well as distributing it with my negative 4. So 8 times negative b minus 8 times negative 4. So 8 times negative b is going to give me negative 8b. And I'm going to be subtracting 8 times negative 4, which is negative 32. I see there a double negative there. So that's going to become positive. So our final answer, negative 8b plus 32, plus 32. Look at that. How lovely. So you're going to be going through on that Nearpod. You're going to be working on some other examples. We're going to start with just this one here. Which one is correct? So which expression is the correct result of applying the distributive property to the following problem? So here, make sure that whenever you're distributing, you're going to be placing those arrows. You're going to be distributing the 5 with each term. I see the first term here is 2x. And the second term is going to be negative 4. So that gives me 5 times 2x minus 5 times 4. 5 times 2x, that's going to give me 10x minus 5 times 4, that is 20. So now, I want to circle the correct answer here, which expression is the correct result of applying the distributive property to the following problem.